guys do not use your Mathemigos to the full extent. Pretty good. Pretty good. Honestly, I can't imagine this class. You're doing great.
I know that the change is positive. Mine is 0, 1, so that's 3. Mine is 3. I do the rest of my stuff. This one. If F double is
You just slow of the change. So the rate is just when I found that it was not time this.
So you're doing that change. So there's the point. So even though you have this like version thing, when you do the upper one minus the lower, you find the spirit. So you don't need to see it's just so you'd be right. So this is 7. So 5. So that's 5. Okay, wait, so this is 5. So that's the rest of it.
Why to right?
Yeah, this is why. It'll even out still I know for a fact that I said that or I mean it could be less than 30 but it's twice. Changes that are ready to change.
Are you ready? One more minute. Tyler, you ready? Okay, cool. On the first one, F is positive, F prime is positive, implies what? How is F prime positive implies?
Yeah, that's
F is increasing. Wonderful. F double negative is sometimes it's hard to use because it implies a couple different things. It applies F as concave down, but I don't really have a graph, so it doesn't help me very much. If you graph the points, it's not a bad way, but it's a bit of a time eater on a test. Instead, you might consider if F double is negative, then that means F prime is decreasing because the derivative of F prime, F double, is negative. So if F prime is decreasing, then that means changes are decreasing. So you might go to the table and think, well, changes are decreasing. So the first change was an increase of 13. Then the next change was an increase of 5. The next change then should be less than an increase of 5. Now then, you should be able to bound this on two sides. If F is increasing, F at 5 must be greater than 25. Okay? But if the changes are decreasing, the next change must be less than 5. Now, if you start at 25 and change less than 5, then your next number should be less than 30. Wonderful. Less than 30. So at the end of the day, I would know that this has to be between 25 and 30. Okay? Usually that would be a multiple choice question, and you would say, which of these is a possible value of f? Okay? This one goes to verbal connections to analytical, translating words into calculus. Changes the rate of means the derivative is by 6 coordinates. So would you put that in calculus notation? Give me something to write. Y prime equals 2x. Wonderful. Okay? Now, if y prime is 2x, then how am I going to get the function y, not y prime? You have to integrate. The opposite of derivative is to integrate. So I get rid of the integral by integrating, or derivative by integrating. Y then is x squared plus c. Okay? It could have had a constant there that went away to give me that derivative, so we don't know. How do I find that plus c? Yeah, we use that initial condition. 4 is y, 1 is x, and therefore c is 3. So the equation must have been, or function, whatever you called it. If you called it f, fine. Y, fine. X squared plus 3 is 0. You with me? All right. Slightly harder is, maybe not. I don't know. We'll see. Okay? If you have a quadratic like this, and f has a relative min at -1, -1, this is commonly done badly because people don't use this in the correct way. Okay? Is this, start by writing yourself a note or being clear. Is this a point on f or f prime? It's a point on f. That's a minimum of f's graph. Now, people, the biggest mistake by far is people will think, oh, relative min, so the derivative. Well, that's absolutely logical, 100%. You bet. But it's not a min on f prime. It definitely, f prime definitely, will be going on there, but be very clear in your head. This is actually two things, two facts given. -1 is a point on f. And f prime at what x value, not y value, x value, at what x value? At -1, what must it be if there's a max there? 0. Now, technically, a max could happen at a derivative 0 or d&e, but does a parabola have this kind of action going on? Not so much. It's got to be something like this. So it also must be the case that the derivative is 0 at x equals -1. Now, together, that's mathematically what you need. Truth about math that you know at this level is that if you have two unknowns, you have to have two equations to work with, okay? And so we have two. We'll have f, given that -1 is a point on f, that would imply that -1 is a minus b plus 1. Plugging -1 in for x, right? And maybe simpler would be a minus b is equal to -2 if you don't have a problem with me moving that around. Are you cool? Now the derivative part. I'm going to box that so I don't lose it because I'm about to do a little more work here. F prime, what is f prime? 2ax plus b. Therefore, f prime at -1 is 0. Where does stuff go? For f prime, I put 0. And for a, I put, x rather, I put -1. So that tells me 0 equals -2a plus b. Oui? All right, now I can bust out the delightful algebra skills that you all have earned over your course at this school. How would you solve a minus b equals negative 2 and negative 2a plus b equals 0? Shall we use substitution, elimination, Kramer's rule, matrices, inverse matrices, graphic? Okay, substitution. I didn't hear anybody biting on Kramer's rule. That's a shame. Substitution, okay, I'm down. B is 2a. Do you agree? And so if you use substitution, it works very nicely. You get a minus 2a equals negative 2. Oops, negative 2, which implies that negative a is negative 2. So a is 2. If a is 2, then b must be 4. Okay? Because b is twice a. So our equation, actually it didn't say write the equation, it just said find a and b. So I guess make sense? Okay. So sometimes I'll do one of these and I'll let you do the other two. Really the best way to get good at these is to practice it yourself. But sometimes they don't give you as much direction. In the previous, they say, hey, here's the function. They gave you a lot of guidance. In this, they're giving you less guidance. F is a quadratic function with this point and that max. Find the equation of the function. If it's quadratic, the first thing I would do is say, all right, I could go lots of different quadratic forms, but unless you're given roots, you're probably going to use the standard form. Actually, that's general form of a quadratic. And find A, B, and C. All right? Now, in order to find three different facts, you're going to need, three variables, you're going to need three facts. So try and tell me, give me one thing you know. What? Point at 0, 3. If I use the point 0, 3, that implies that 3 equals 0 plus C. In other words, the y-intercept is 3. Boom, we already found C. C is 3. And now it's really more of a two unknowns. All right? Wonderful. Good start. Give me two ways to use that fact, 1, 4. Max at 1, 4. What else do you know? Is 1, 4 a point on F or a point on F prime? It's a point on F. And so if it's a point on F, that implies that 4 equals A plus B plus 3, or A plus B equals 1. Okay? We used it as a point. What's another way to use it? It's a max, yeah. Okay, F prime at what? At 1 equals, at what equals what? Does it equal 4? Or does it equal 0? 0 if it's max, right? Using that fact, then obviously to use that fact, we'll need F prime. F prime is 2ax plus b, right? And so if I use zeros and 1s, then I get 0 equals 2a plus b, correct? Together that sets up a system of 1 equals a plus b, and 0 equals 2a plus b. Substitute or eliminate. Whatever you want to do. Substitute or eliminate, I don't care. But tell me what a is to you. A is negative 1. And b is 2. Okay? You can at least 4. That seems reasonable. It should be opening down, so at least the A sign seems like it's right. Okay. Would you try the other two on your own with your mathematics? We'll go over it. Oh, happy day. More math talk, people.
Oh, you know why? You're not finding the first one. When it just goes to there, you're just finding a line. So you're not doing the minus. Here's some square. First time in history.
Okay, what'd you get for the A, B, the quadratic? Or what was your quadratic, rather? F of x equals? How many x squareds? X? What? A. What's A? Oh, yeah, I get you, but what was A? You don't know? Thank you, Esther. Okay, so we don't agree with Esther. My faith is in Esther, so what's wrong? We are good? Okay, so what's everybody saying what? How many x's? What? 4 x's? 0 x's? 4 x's, cool. And the constant? -1? Perfect. Okay, this is a little harder one. It requires you thinking outside the box a little. Did you make good headway? Okay, let's talk about, a good mathematician talks to himself a lot, okay? So if f has no relative extrema, what does that imply about f prime? Doesn't change signs, and the only way it could have changed signs is if it had critical numbers. So f prime has no sign changes. I love that. That's awesome. And therefore, it has no critical numbers. So f prime is never equal to 0 or undefined. Great stuff. Okay? F prime is 3x squared plus 2bx plus 2, yeah? This does not have any zeros. Now here's where we connect to big ideas of algebra. Why wouldn't that have a zero? Do all parabolas have zeros? Okay, when does a quadratic equation not have real zeros? Okay, think of the quadratic formula. When you work the quadratic formula here, when does this come out non-real? Yeah, if there's a negative in the root. So to really get through this, you would have to connect to the fact that, geez Louise, that would mean that 2b, don't you agree that the x coefficient is actually 2b? 2b squared minus 4, 3, 2 must be negative. That would imply that 4b squared minus 24 is less than 0. So 4b squared is less than 24. So b squared is less than 6. Does that mean b is less than 6? Square root of 6. It's between. So do the algebra this well. If b squared is less than 6, that implies right and left hand. That b must be between negative root 6 and positive root 6. You could also see this sometimes written as the absolute value of b would have to be less than 6. Okay? That was a hard one. You good? Okay, let's try curve sketching. You'll find that this used to be like top 5 ideas of all calculus. That was before the graphing calculator. Since the graphing calculator, you can get an idea of the curve with the graphing calculator. But old school people, if you want to graph something that was totally unfamiliar, if I told an old mathematician, hey, graph that, they wouldn't just plot points. That's ridiculous. That's a waste of my time. I'd say, what is the domain of the function? What does the derivative behave like? What does the second derivative behave like? And through analyzing all that, I can sketch it, no problem. Okay? Now, I will not make this a huge focus of this class because you do have a graphing calculator. But that said, there are a lot of colleges where you don't use a calculator on any AP exam. Curve sketching is on any exam. And curve sketching is a part of the exam. On your homework tonight, there's a problem from CU's final. It's number 20 on tonight's homework. That was straight from CU's final a year or two ago. They still expect you to be able to curve sketch, right? So, this involves 100 different gatherings of facts. If you were to sketch something that you had no idea what it looked like, some of the stuff would be, first of all, what the function tells you. Now, you should know lots of shapes. For example, cubes are this. Or if it's any x to an odd, you know it goes up to the right and down to the left. So you have all these, I know this kind of thing. Now, be careful, please, not to overuse shape knowledge. Let me give you an example. If I were graphing this, you would be a fool to think that this is a parabola or this shape. It's not either. It's some kind of amalgamation of those two, all right? So don't overuse shape knowledge. If it's a known shape and something else, well, then all bets are off. Okay, you're talking a combination. All right. Domain. There are 3 restrictions on domain. Please tell me you know at least one of them. What's one thing that cannot happen? Oh, you'll break math. Denominator 0. Boom. Okay? Those usually mean vertical asymptotes or holds, depending on if it's 0 over 0 or just 0 in the denominator. What else? Negative inner root. Wonderful. There's one more, and that is natural log or any kind of log of 0 or negative. None of those are allowed, and so those will mean places where the graph cannot go. Domain restrictions, yeah? You know, end behavior. End behavior amounts to what happens as x goes to infinity and negative infinity. Do not always assume they're the same. Just because the graph goes to 2 on the right side doesn't mean it has to go to 2 on the left side. That's not the case. Okay? Symmetry, that's especially with even or odd. If you know that if you're given that a function is even, then you know it's symmetric at the y-axis. If it's odd, you know it's symmetric about the origin. So they might tell you a function's odd. In which case, every point they give you, they're actually giving you 2 points. If they tell you it's odd and it passes through 2 3s, you know it also passes through -2, -3, and the origin. Good point. That's absolutely true. You're right. Okay? Assuming it's continuous. Zeros and signs. You can find where the graph is above or below the axis and find x-intercepts by looking at the zeros of the function. Okay, now all that's pre-calculus ideas that tell you about the function. We also know that the first derivative tells you where a function is increasing, decreasing, horizontal tangents, if f prime is 0, or f prime dne. That could actually be 3 different things. Why might f prime dne? A cusp, okay? If there's a sharp turn, that could be a reason why f prime dne. Why else? Discontinuity, okay? Or vertical tangent. If a graph goes vertical, then the derivative would not exist. All right? What does the second derivative tell you? Concave up, up, concave down, or inflection points, also saddle points, but we'll talk about that later. All right. Okay, so you should be able to, this we've done before, you should be able to sketch from a table. These are the easier ones. Given a table, sketch the graphs. Go. Look like they're done with the first one. Should we talk about that first before we go too far? Okay, so do you agree with my assessment about increasing, flat, decreasing? Although the undefined spots, I don't really know what's going on there. I'll have to get to that in a second. So increasing. I don't even know concavity. I could say it's increasing, okay? Actually, if it's going to go flat, then it probably has to. It could be that, it could be concave up, I don't know, it doesn't matter, but it's going to turn flat, yeah? All right, then it decreases. So it seems like we just had a max, All right, at the point 6, it needs to go from decreasing to increasing and be undefined. What's the reason it might go decreasing to increasing and be undefined? It can't jump because its continuity, but it could do sharp turn. Now the hard part to me was going on at 7. What's 7? It's undefined there, and then increasing after. So what could be going on at 7? A hole can't be a hole. It's continuity. There's continuity. Could be one of two things. It could be a vertical tangent, F prime D and E, because there's a sharp turn. Discontinuity's out because they said it's continuous, or vertical tangent. So you should be trying to work in either a sharp turn or a vertical tangent. Now think linearly. How could there be a sharp turn or a corner there if it's increasing and then increasing again? Could it be like that? All right, now that would work. Okay. Another possibility is if it was increasing steeply, went vertical, and then increased. That also is another possibility. So there are a couple possibilities. You with me? All right. Try 2. Sorry, I'll let you do that. Again, there might be a couple possibilities here. Actually, I shouldn't be giving you so much. Okay. Laney, x is less than 0, the second derivative is positive. That implies f is concave up. That's concave up, so any piece of that kind of shape would work. So let's say we went, I don't care, like that. Then if afterward the second derivative is negative, then the curve goes what, Tori? Sorry. The concavity I mean 0 to 3, what's the concavity? Concave down. If it went from concave up to concave down, it had to have an inflection point there at 0, right? It could have looked a lot of different things. It actually could have looked like that. The increasing, decreasing is not there, so any of these would work. Actually, it's 2 and 3 look exactly the same, so that's then concave down again. It goes undefined and then concave down again. So what does it do? Sharp turn. Yeah. Sharp turn, like something like this. Like, let's go here. This is concave down, but all of a sudden it's different concave down or something. Yeah? This one may be easier to do. Here's another idea. Concave down, could be a sharp turn kind of there. Wouldn't that be up, down, down? That one's kind of fun. Okay, let's try the hardest of the bunch. Curve sketching. These are going to require you to collect a lot of facts. Tell me this. What's the domain of this bad boy? Any restriction? No. Okay, so it'll continuously go left to right. Boom. What's the shape? X to the sixth. X to the sixth should have what end behavior? On the far right and far left, it should go up and up, okay? All right, cool. What about zeros? Plus or minus 1. Okay, cool. What about in terms of F signs then? Less than -1. What's the sign? Say at -2. You would get what kind of result? Positive. At 0. Negative. And after 1, positive. Okay, so I know where the graph is above and below the axis. Sounds good. I can't think of anything else to go with the function, so let's move along and go to F prime. What's F prime? 3 times x squared minus 1 to the second times 2x. What's that equal to 0? Define where it goes flat or has critical numbers. This would have critical numbers at 0 plus or minus 1, yeah? X equals 0 plus 1 minus 1. If I sign test, then the derivative, what if I plug in -2 into the derivative? What do I get sign-wise? This is definitely positive, but 6x is negative. At -1/2, this is definitely positive because it's squared. That's still negative, so that's negative. So it went negative, flat, negative. At 0, it went flat. At 1/2, sign positive, and after 1, positive. So I know it's going to go, F is going to go decreasing, flat, decreasing, increasing, flat, increasing. Okay? Good stuff. Finally, let's go to the second derivative. This is where your calculus and algebra skills have to be rock solid. So let's go to this form of the derivative. The second derivative by product rule would be first stays the same. Derivative of the second is 2 times x squared minus 1 to the first times the 2x. Wouldn't you agree? Plus second stays the same, x squared minus 1 squared times the derivative of the first is 6. Let's take out a greatest common factor. We can take out what? 6. How many x squared minus 1s can we take out? 1. I think that's all we can take out of everything. So if I take out the 6 and the x squared minus 1, then what's left from the first product? 4x squared, I agree. The next one, I took out the 6 and un-x squared minus 1, so that leaves me with another x squared minus 1. Do you agree? So I have 6 times x squared minus 1 times 5x squared minus 1. You concur. Alright, this is 0 or undefined at x equal 1, plus or minus 1, and plus or minus what are the zeros of that? I guess we'll show it. 5x squared minus 1 equals 0. So x squared equals 1 over 5. So x is plus or minus the square root of 1/5. Yeah? Are you with me? All right. If I go if nothing else, this will make you appreciate your fancy pants graphic calculator, because this is very much how you did. I mean, you graphed everything this way. Every time you graphed one that was complicated, this is how you did it. So at -2, this is, I feel like this would be positive and this would be positive, so that's positive. But if I were to do a half, this would turn negative while this would stay positive, so it's negative there. If I went to 0, I get 6 times -1 times -1. That's positive. After I trip over or get past root 1/5, it would be negative positive, so that's negative. And after 1, positive. So that implies that the curve is concave up, down, up, down, up, and I have 4 inflection points. Are you with me?
Yes.
Okay, so here we go. Are you ready to finally graph this? I know I have zeros at 1 and -1. And I know the graph should be up, up, down, and up, right? Okay. Just for kicks, what's the y-intercept? Well, I have the x-intercept, but what's the y-intercept? What's the y-intercept? -1. Yep. Okay. That's good stuff. All right. Now then, from negative infinity to -1, tell me 2 things about the shape of the curve. Decreasing, concave up. Decreasing, concave up. Okay? After you pass -1, what happens? It's still decreasing. It goes flat there for a second. Oops, I missed it. I missed my flat spot. It goes flat at -1, right? And then what happens after -1? It turns to decreasing, concave down. So decreasing, concave down. Until it gets to square root of -1/5. Or negative square root of 1/5, rather. Sorry. At that point, it turns to, it's still decreasing, but now it's concave up. When it hits 0, it goes from decreasing to increasing, but the second derivative had nothing to do with 0. So what's the concavity still? Up. All right, so it's going to turn increasing, but to concave up. What happens at positive square root of 1/5? Still increasing, but now it turns concave down. Shucks. Okay? At 1, 3 things happen. It goes flat, and as far as increasing to decreasing, it goes back to increasing, but it turns from concave down to concave up. That looks even. Does that make sense that that would be even?
Yes.
Yeah, it's the 6. It's even. Okay. All right. That's curve sketching. I don't know if we have time to do. Maybe we have time to do the next one. Shall we do the next one? Do the domains. That's easy. All right. Do we have? I'm sorry. We don't have time to do that. How'd the fun sheet go? No questions? Just ready to turn it in? I tried to give you on the key the bare minimum. I gave you the answer and I gave you hints, but I didn't show my whole worked out key. So I guess I would like you to look it over. Maybe we'll do a fun sheet on Monday so we can do a catch up on questions. What do you think?
Yeah.
All right, cool. So nothing's due today. On Monday, we'll go over the test and go over 2 homeworks. So yeah, oh, sorry, would you like to see your first page of your test? All right, with the 2 absent people, let's go in the hall, please, Kylie and Jill. Don't sit in the hall, it's filthy, but whatever. So your first page.
Full Good morning, Evelyn Jackson. Please rise for the pledge of allegiance. Ready? Begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Put your phones away if you're gonna get your pets back.
Girls Ventures will have their annual cookie celebration on Friday, December 7th in the cafeteria. Mentors, please bring coffee and many favorites, sprinkles, and decorations. Please come directly to the cafeteria.
Boys Centering will meet in their assigned room today for attendance and snacks. Leaders will give you directions for today's activities, and mentors will be mentioned for the agenda. Please let Mr. Roquay know if you have a conflict.
Interact Club, don't forget it's meeting today. Sign up and make mistakes when we head to the library.
For those 7th and 8th graders who indicated on the counseling needs assessment in September that they would like additional support with study skills, you will be required on Monday, Tuesday, or Wednesday next week.
Warriors boys basketball game on Tuesday, December 3rd from 5 to 7 p.m. 5 to 9 p.m. school day on South Plaza Boulevard. Be sure to mention Devlin.
Oh my gosh.
Hey Jack, stay warm with the swimmers. Purchase a cozy Jaguar blanket from the DHS tier team for $10 to help fund our national trip. They're going fast, less than 10 laps, so hurry to any of your DHS cheerleaders.
No, of course not.
Consider participating in Cause for Cause, a Devlin Giving Tree Gift Drive. Stop by the Giving Tree display in the main office. Each of the paw ornaments on the tree has a gift or age on the front as well as instructions on the back. Feel free to take ornaments to the tree back the unwrapped.
Yes, he doesn't like it.
Are you looking for ways to pay for college? Counseling is offering a scholarship workshop on Monday, December 3rd during 7 hours. The subject will be on tips to make an impressive scholarship application. Sign up at counseling.
Girls lead the way in STEM and